Physics Part 400. Exam style questions for the section. Question number 6. When an alpha particle travels through air, it loses energy by ionization of air molecules. For every air molecule ionized, approximately 5.6 into 10 to the power raised to minus 18 joules of energy is lost by the alpha particle. A suggests typical value for the range of an alpha particle in air. Hence, estimate the number of air molecules ionized per millimeter of the path of the alpha particle, given that the alpha particle has initial energy of 9.2 into 10 to the power raised to minus 13 joules. B. It has been discovered that the number of ionizations per unit length of the path of an alpha particle suddenly increases just before the alpha particle stops. State with a reason the effect that observation will have on your estimate. That's end of chapter number 13, Nuclear Physics. And here we start chapter number 14, Electronic Sensors. Chapter 14, Electronic Sensors. Electronic sensors have become such everyday items that we hardly appreciate them. Except when they fail to work, some sensors are simple, such as those detecting temperature in a thermostat or detecting light levels in an automatic switch or switch for a lamp. Other sensors may be more complex and used to control systems. For example, in the braking system of a car, an electronic circuit may be used to sense whether a wheel is skidding. If it is, then the circuit controls the brakes not only to stop the skid, but also to prevent further skidding. An electronic sensor may be taught to consist of three parts: a sensing device, a processing unit, and an output device as illustrated in the figure. Section 1, 13.1, Sensing Devices. At the end of section 13.1, you should be able to show an understanding that an electronic sensor consists of a sensing device and a circuit that provides an output voltage. You should be able to show an understanding of the change in resistance with light intensity of a light dependent resistor, LDR. You should be able to sketch the temperature characteristics of a negative temperature coefficient thermistor. You should be able to show an understanding of the action of the piezoelectric transducer and its application in a simple microphone. You should be able to describe the structure of a metal wire strain gauge. You should be able to relate extension of a strain gauge to change in resistance of the gauge. The sensing device is the first stage of any electronic sensor and is the means by which whatever is to be detected or monitored is converted into an electrical property. This electrical property is frequently resistance. A physical property of sensing device changes with a change in whatever it is monitoring. Sensing devices are available that can be used to detect many different types of change. For example, changes in light intensity, changes in temperature, changes in sound level, changes in humidity, changes in pressure, changes in strain, or changes in magnetic field. Some of the more common sensing devices will be considered later in the section. Electronic sensor, sensing devices.